Hi, and welcome to Quick and Maths on trigonometric ratios. There are some fundamental numeric sets of trigonometry which will be provided in the table on the bottom right as we run through each slide. We start with sine 30 being 1 over 2, and in a pictorial right-angled triangle, it is as shown on the top right. From the pictorial representation, the length of its adjacent side can be calculated using Pythagoras theorem as root 3. Also, its last angle of the triangle is simply 60 degrees. With this filled up, we can identify the sine, cos, and tangent values for when they are 30 degrees and 60 degrees. Next, we know that a 45-degree right-angled triangle has its adjacent and opposite sides being equal in length, which we are choosing to place as one unit on the diagram at the top right. From this diagram, we can identify the length of its hypotenuse as root 2. From the filled up diagram, we should be able to populate the sine, cos, and tangent values for when they are 45 degrees. I'm going on to complete the table for 0 and 90 degrees. And the same applies when the angle is specified as a radian. With the table being completed, we could now, for example, state the exact value of the product of sine 45 and sine 60. With this knowledge, this equates to the product of 1 over root 2 and root 3 over 2, which simplifies to being root 6 over 4. Tutorial question 1. Theta is an acute angle with its cos theta being equal to 1 over 5. Find sine theta square plus cos theta square. When cos of theta is equals to 1 over 5, its adjacent can be thought of as 1 and its hypotenuse as 5. Using Pythagoras theorem, its opposite can be calculated as the root of 24. Thus, sine theta is equal to root of 24 over 5. By inserting the cos and sine values into the expression of sine theta squared plus cos theta squared, we will be able to identify this as 1. Next, we shall look at trigonometry in a coordinate system. In pure maths, we've seen this as a coordinate system represented in the form of its x and y coordinates. The coordinate system can also be represented by the r and theta parameters, whereby r is measured from the point 0, 0, and theta is measured from the positive x direction in an anti-clockwise direction. Therefore, when measured in a clockwise direction, theta will be represented with a negative sign. Do take note on this being different from how an angle is referenced in the subject of bearing. Let's start with theta being in between 0 and 90 degrees when it is in the first quadrant, and its x and y being positive values. By making its acute angle with reference to the x-axis as alpha, in the first quadrant, alpha is equal to theta. And its sine alpha will be the positive y over r, its cos alpha will be the positive x over r, and its tangent alpha being a positive y over x. All its trigonometry ratios have resultant positive values in the first quadrant. Now when theta is between 90 and 180 degrees, which is in the second quadrant, its x is a negative value, whilst its y remains a positive value. By making its acute angle with reference to x-axis as alpha, In the second quadrant, alpha is equal to 180 degrees minus theta. In this case, sine alpha is a positive y over r, cos alpha is a negative x over r, and tangent alpha is a negative y over x. In the second quadrant, only its sine ratio has a resultant positive value. As theta gets to between 180 and 270 degrees, which is in the third quadrant, both its x and y are negative values. Again, with alpha being the acute angle with reference to the x-axis, in the third quadrant, alpha is equal to theta minus 180 degrees. Here, its sine alpha is minus y over r, its cos alpha is minus x over r, and its tangent alpha is positive y over x. In the third quadrant, only its tangent ratio has a resultant positive value. And when theta is in between 270 and 360 degrees, which is the fourth quadrant, its x is a positive value, whilst its y is a negative value, with alpha being the acute angle with reference to the x-axis. In the fourth quadrant, alpha is equal to 360 degrees minus theta. Here, sine alpha is negative y over r, cos alpha is positive x over r, and tangent alpha is negative y over x. In the fourth quadrant, only its cosine ratio has a resultant positive value. In summary, and in going with the flow by quadrant, the resultant value is positive following the acronym ASTC. This is when all trigonometric ratios have resultant positive values in the first quadrant, and only the sine in the second, the tangent in the third, and the cosine in the fourth. Add sugar to coffee was the phrase I used to help me remember this until today. Tutorial question 2. Express the values for the two stated expressions. Sine negative 120 degrees is equivalent to sine 240 degrees. The angle being in the third quadrant with an acute angle of 60 degrees makes this the value of negative root 3 over 2. Tangent negative 225 degrees is equal to tangent 135 degrees. This angle is in the second quadrant and has an acute angle of 45 degrees. With this, it is equal to minus 1. Tutorial question 3. Given that tangent theta is minus root 3 for theta being in between 270 and 360 degrees, find sine theta and cos theta. The acute angle for tangent theta equals root 3 is 60 degrees. With the given theta being in between 270 and 360 degrees, which is in the fourth quadrant, it suggests theta is 300 degrees. Hence, we are to identify the values for sine 300 degrees and cos 300 degrees. In the case of sine 300 degrees, it is minus root 3 over 2, as sine is negative at its fourth quadrant. As for cos 300 degrees, it equates to 1 over 2, as cos is positive at its fourth quadrant. Tutorial question 4. Given sine A being equal to minus 12 over 13 and cos B being equal to 3 over 5, where A and B are in the same quadrant, find tangent A and tangent B. From the given info, we could put up the triangles representing what is said. And by applying Pythagoras theorem, the adjacent length of A is 5. Also, the opposite length of B is 4. Also, from the given data where cos B is positive and sine A is negative, it implies that these two, being in the same quadrant, are lying in the fourth quadrant, where tangent A and tangent B would also be of negative values. Leveraging on the triangles, tangent A is negative 12 over 5, and tangent B is negative 4 over 3. That's all for trigonometric ratios. If you found this beneficial, do continue to view our other videos in the KT tutorial channel.